questions or comments you wanna, you've been listening to this stuff all day, Harold?
Yeah. You want me to comment on today? Nick's presentation, like always, is very, very good. Lots of information, lots of agronomic stuff that I forgot about. Missed the genset one, but that's irrigation motor efficiency, fantastic. Jordan's presentation, always good. We're forage growers now, so everything, whenever Jordan's speaking about sorghum, I'm just, my ears to the ground, just listen to what she has to say. Everything that she said is what we're seeing. You know, we chopped corn 2 years in a row, 22 and 23, never had chopped corn before. And the long-term effects of that, it took us a couple of years to get over that. So we went back to cutting, harvesting, raising corn for grain, so we could have to build up our residues again. Especially with our reduced irrigation capacity, I think that was very important. What else?
Did you say you used a lot of spritzer fields between corn and silage?
Yes.
Or between corn
Sorghum
and
silage is a great companion crop to corn. Initially, we were planting our corn first, our sorghum silage later, mid-June to late June. And the second year, we swapped that around. We started planting our sorghum silage as early as May as we could, as soon as the soil temperature allowed us to get some good germination. That allowed us to start chopping our sorghum silage in August. And as a result of that, and this was just by mistake, this wasn't planned out, we get a regrowth on our sorghum silage, so we have residue about this tall growing from regrowth of the sorghum silage. And at the same time in August, we can move our corn, concentrate our corn back on our water back on our corn crop and raise a good corn crop. So great companion crop. The biggest challenge is the dairies and their demand. I think it'll continue to increase, but we had a big silage year last year, so they cut back acres quite a bit.
for a couple of years. There's been a lot more silage made, and now they're all got miles of stuff that can't get fed up.
There's mountains and mountains of silage, but that'll, as you know, that can change pretty quick.
You know, one thing I just thought of with that regrowth, that's pretty nice, pretty efficient, is you've already got a, if you will, a root package that's developed.
Exactly.
So that regrowth isn't a big waste of resources or efficiency, and it comes on really quickly as well, because you've already put that effort into building that root structure, so that's nice.
It gets to be awfully tempting to want to chop it second time. And it'll get,
Double
it'll
dip.
it'll get pretty tall. So it's a nice companion crop.
Do you no-till into that? Do you stuff to
Yes,
it?
you can. We did some just at a limited basis last year, but this year we're going to be no-tilling our corn into it. This, right after the initial freeze, it's still standing tall, and you think there's no way you can go through it, but it starts breaking down. So right now it's all broke over, and then it'll decay a little bit. And so,
30-inch spacing?
pardon me?
30-inch spacing?
Yes, 30-inch spacing.
Helps if you get a snow.
I guess there's still time.
One-
That'll probably be April.
But I mean, it would help it.
Yeah, it would
lay
help.
down, and probably better if you
Yeah,
got
well,
some snow.
yeah. This year it's still a long time because we just didn't get any
Getting
more.
the snow's just about as harder than getting rain.
And we really haven't had the big winds this winter in December like we had the last few years, so.
Knock on wood, hopefully.
The question just a moment ago, you know, it seemed like there was a lot of overlap in the presentations today, and it felt like all of the stories were kind of in the same direction. For me, that was really encouraging, because it feels like a lot of us are on what feels like the right track of consistently getting better. One of the things that I think didn't get brought up related to the spacing is with declining water in your sprinklers, if we're thinking about the application uniformity and efficiency of the sprinkler being, say, on 30-inch spacing, but what do you do with those tiny nozzles towards the inside two spans? that's one of those places where it's probably wise to look at a wider drop spacing on the first couple of spans, so you get your nozzle size up for function. Then once you get up to span 3, 4 and on, go back to that 30-inch spacing. But that was just something that I realized that none of us had really talked about. That's one of those free, practical things that's gonna save a lot of headache.
That's one of the things we did after one of our master marketer. We had several of our guys go through master marketer, or master irrigator, sorry.
That's right.
I've got it both.
What?
Master irrigator. We spent a lot of money one year to get about the last half of all of our sprinklers to 30-inch spacing on our hoses. And some of them maybe only 3 towers for a quarter miler. But I think that's helped us tremendously. Just
The
a lot
grand
more.
side ones are what, 60?
They're still 60s. Yeah, the first tower, every other one is locked off. And we'll block them off early for a while until the crop gets big and turn it back on. Just that first span, because it always puts out twice as much water as you need. That's been a real big help. And different pads for different applications.
Yes.
That's helped tremendously.
So which pads do you use and for what applications?
Well, like the overhang, we use the green pads, and you literally see nothing, no steam, or not steam, but the water vapor coming off of it like you see the next span over. And I took a picture of it because it's so different. So probably we'll keep going further in with the green pads, but I don't want to get too crazy with it, because of course as you go in, the crop protects it. It'll do its thing. But we use the green pad with the bubbler pad on the other side, and with the Chinese, we call them Chinese hats. I don't know the actual term, but the little black deflector that makes it look like a shower head, and that you can see huge difference. Where we've got some without them, but we have them on the outside, and you can see right when it changes, there's just a lot of water vapor being lost. So we just put a lot of money into trying to get every bit of water on the ground and off the plant as we can.
So you're running 60s up close and then 30s on the outside.
Right, and it's pretty much inside half is on 60s, outside half is on 30s. Cleaning it out is a nightmare, but that's a lot of nozzles to worry about. But it pays.
Yeah, how often
It pays.
that's one might just, how often you check nozzles?
Every time you turn it on. And then early, we check them pretty often until it kind of gets, when it starts to clear out, you're fine. But if you ever stop it and turn it back on again, we walk it.
Harold, what do you do?
Same thing. I can't remember at what point we make the transition from 30s to 60s. I think number 6 nozzles, 7, 8s, something like that. I think we've changed that over the years. But
Remember?
otherwise the nozzles get to be too small, especially if you're on 30-inch spacing. If you try to go all the way to pivot like we did initially, your nozzles are so small and they're just, you're unplugging nozzles.
Can't
all the
clean
time.
them out, it's
No,
worse.
you can't clean them out. One of the things we thought of, and we haven't done this yet, but to get a little bit more even distribution on these inside spans on low gallonage sprinklers is putting mobile drip on those first 3, 4 spans and putting it on 30s, and that way it eliminates the small nozzles. And so we haven't done any of that yet. I think Tom Moore did some a couple of years ago. So I think that's something we need to look into.
You don't have much trouble at all with the mobile drip plugging a hose?
No, well, that's one of the reasons why we turned away from it for years. The drip line that we were using initially had a pressure compensating emitter, so you didn't have to have a regulator on it like us. We do have regulators on ours now, one for each drop or one for each one of those boom lines, or several per boom line. We kept having emitters plug up, and we have, if you look at your well logs, we couldn't figure out what was happening. We thought it was iron bacteria at first, and then they thought it was drip oil that was plugging things up. And come to find out, it was clay particles. We have a lot of clay formations in our in our well logs. And it's just a crazy thing. We finally cut them open, and you could see just a fine, it's just like this pasty clay
It's paste.
that was just plugging up the emitter. So we pulled off all the drip line and put a different type drip line on that doesn't have a pressure compensating emitter. It's got a little bit bigger emitter when you cut it open, and it was made to pass fine particles through it. Since that time, we haven't had any issue. Knock on wood, we won't find that this year.
You know, for just about all drip applications, it's a system as well, where you have, the ideal system is 2 different filters in series, and then it goes to the emitter, and by design, most emitters will pass anything that can get through those filters. So there's a number you're shooting for.
Yeah.
But with this one, we're maybe trying to run it without filters, or it's to that point, that pressure compensating ones. It's a lot more traffic and maybe a lesser pressure than you normally would use that drip tubing for in what it was originally designed for. So it's a little trial and error. I'm glad to see that you decided to cut it open. I'm a savage with a knife when it comes to drip. It's
Well,
like, we can repair it,
was-
but this is my diagnostics, is I'm gonna cut this. I wanna see what's growing back through that emitter. I wanna see if it's clay. I wanna see if it's something black or something red, and then you can work on it from there. But it's hard to know what's going inside that.
Yeah, it is.
Okay, let's keep on. More questions. Got the expert leaders here. Okay, Nick, I have one thing again. We're going back. Kind of tell them about the operation and you kind of manage or help manage and what kind of systems you use and why.
Currently.
Currently.
Okay. So I have a couple of properties in Southwest Arizona, the Imperial Valley, and Palo Verde Valley of California, then the Central Valley of California. That is really diverse. Like I mentioned, there's 0 center pivots in any of that. One of the properties, the one in Arizona, was 3,500 acres of subsurface drip alfalfa, all contiguous. Recently, that was traded over to a low water use native fiber crop, which is pretty fascinating. So this is the first year that that whole ranch has been planted to that crop. Again, though, this is 40-inch centers, subsurface drip irrigation, all well water. So these are deep wells. Those wells are drilled to 1,600 to 1,900 feet deep, pumping from about 400 feet. That whole ranch has 2 filter stations that it goes through. One is about 60 pots, and one of them is about 50 pots, and there's just pipelines everywhere in the middle of the desert. I mean, you would drive by this and think, who in their right mind would do something like this? So that's one end of the spectrum. The other end of the spectrum is developing almonds in the California Delta. We tried to develop some almonds in Arizona. That was a really good project, studying weather and elevations. And the almonds in the California Delta are really interesting. Like I mentioned before, because that whole ranch is below sea level. And almonds are a Mediterranean plant that doesn't really care for wet feet. And so all the things like salt-borne fungus is a challenge, saturation is a challenge, weather is a challenge because of the timing of that plant. But this is a farm that went all the way from the start of a reclaimed marsh to a leveled, sub-irrigated property to now one that's got tile drains all throughout it. And the irrigation system is dual line drip and micro emitters, because you also use the irrigation system to prevent frost. So talk about intense management. It's just a really cool system, doing all of the things that we talked about today, those principles, using it for an application that really is kind of novel. The things to keep in mind, though, is these are high value crops. It's not uncommon to have $7,000 to $8,000 per acre revenue on a crop like that. And so on the front end, you're committed. Once you're in, you're committed. And I would say it's not for the faint of heart, and most everybody that touches anymore is kind of faint of heart. So there's about 6 years of heavy panic until these trees start to produce, and then about 6 more years of paying yourself back, and then if the market stays good, you can be producing for a while. But really interesting systems. And then between all that, we've got tomatoes and melons and
Yeah.
all these fascinating.
How about rodent control? That came up. Is that a problem?
It's a major problem, absolutely. Most of this is surface irrigation, and so you do have trouble with rodents. Typically, the rodents are more of an issue in the drier areas where they're seeking out water. One of the best tools for rodent control is keeping it damp if you can. But there's not really good tools to take care of all the rodents. You're baiting, you're trapping. One of our worst rodents is beavers and otters. So you hire a hunter.
Might be possible.
Yeah, interesting, really interesting. Worst rodent I had, and I did a stupid thing, I've told Stan this story. You prevent frost, and so we installed some orchard fans, and the transition there is that we've got an inversion layer, so when you're fighting frost, you've got this temperature that you've stored during the day, the temperature gets cool at night, and so the cold air is heavy, displaces the warm air, so you've got a fan 60 feet in the air, you turn it on, and it's basically like a big old helicopter blade that just starts to mix it back down. Well, that motor out in the middle of the field also becomes a real attraction for rodents. And so you've got these mice nests in there and the rats that get in. The worst I had was a rabbit that got caught in that. And it's a V-based motor. Stan, I don't know if you remember this story or not.
Yeah, I remember. I think you were panicking when you told me
I
that.
did, yeah. I got worked myself out of it, thank goodness. But I had to have this motor running, but there's a rabbit in the middle of it, in the midst of what was like a rabbit trapping, and it was the V, and then the intake manifold was over it. But that rabbit was hanging out there. Well, I thought, I'm not going to get bit by this thing. I'm just going to shoot that rabbit and then drag it out of here. So I took my rifle, shot the rabbit, and then realized, you moron. I also shot my coolant line that I didn't know was running through there. So in a rush, you know, 60 miles from civilization and 120 miles from the nearest dealership, it's like, hey, do you perchance have this part? Because I'm heading your way. But yeah, rodents from start to finish are a challenge, no doubt about it.
Justin, how low are your drops? Are you doing Mesa, Lisa,
But
Lipa?
it's about as close as we can get. When they're running, you know, they stretch down there about less than 18 inches or so. We try to keep them low.
Harold?
Same, as low as we can go. As low as we
Low
can
as you can go. Because, you know, when I go through we do an initial survey when the class starts, and we're still looking at 30% of the acreage being Mesa, median elevation, which I don't know if it's necessary or not, but I think we need to go lower. Harold, how'd you come up with the 2.5 figure, 2.5 GPM between your,
Just, you know, initially, I think our first system, the emitters on the drag line was 1 gallon per hour emitters. So initially, we were gonna go with 60-inch spacing. And that's when Leon was here, and he was helping us design this thing. And we were gonna have drip lines that were just, it seemed like 40-foot long. So we decided to go to 30s, and that shortened them up a little bit. But then what we learned is, because of the efficiencies of LIPA, there's not a lot to gain, in my opinion. Well, I'm talking out of both sides of my mouth here. It just seemed like, if you have pretty good irrigation capacity, because of the maintenance involved with the mobile drip, you're better off just sticking with LIPA. It's just a lot easier system to contend. But when you get down to these lower gallonages, below 3 gallons, below 2.5, I think that's where mobile drip really has its place. That way you can put up with all the maintenance.
okay?
But even if you have plenty of water you take a couple of towers or 3 on the inside are useful to go to the drip.
Yes. Or what you could do, if you want to get really extreme about conservation, you take your 500-gallon well and you just pump 250 gallons. And you start getting, if you want to extend the aquifer and get serious about it, that's what we do. But we're not going to do that.
Well, I can see where you could have a lot better distribution of your water all the time rather than just some of the time, because them dang drops or those little emitters, they just always, you know, you can clean them out every day just about, some of them.
Yeah, the
and they'll be
emitters-
stuck, plugged up the next day.
You can't unplug an emitter. I mean, we were out there pulling plugs and beating on them with sticks, and they'll flow for a little bit and they'll just plug right back up. Once that emitter's partially plugged, it's hard to unplug them. But also, when you start getting into these, unless they come out with a bigger emitter, like a 3 or 4 gallon per hour emitter, you can have drip line. If you have a 500-gallon well, or 5 gallons per acre, you're gonna have some pretty long drip lines behind your sprinkler. And that's
What are
just-
the average length of your lines now? 20?
20 foot?
That's on the inside towers, or that's,
No, the inside tower is like 2 foot.
yes, with the 2 emitters, right?
Yeah, there's 2 emitters.
Yeah.
The outside gets pretty long on the half milers, but it seems like.
Yeah, the half miler, so that's a 600, we're running 600 gallons through a half miles per people. And that's less than 3 gallons. And that's the only way we could make that work.
Hey, Harold, how well does that outside one track the circle when you're going through?
Tracks really well.
As you'd think it might shortcut, but you just don't see that, do you?
No, you don't.
So why haven't you went all mobile drip then?
We want to give it a couple more years before we expand that.
Better emitters.
Yeah.
I think Harold really hit on it. Justin, you probably got an opinion on this too. It seems that LIPA in this area really has hit a nice sweet spot. And like we talked about, having residue and carryover material on the surface just answers some of those major questions, where it starts to close that efficiency gap a little bit.
Exactly.
Because there's no system that I've ever been around. Well, I shouldn't say this. I spoke to some dryland guys really just touting irrigation and touting how just amazing LIPA is, and based on that meridian line, like what Jordan showed, they said, well, it ain't that amazing if you don't need to irrigate, because nothing's better than no irrigation.
Absolutely.
But if you do have to step into the irrigation world, LIPA is as turnkey as it can be. And what I really think of with the operations is one guy can manage 10,000 acres, basically. Where if you were on drip or mobile drip, you're gonna have to have lots of guys regularly chasing that to manage some of it. So I'm all for efficiency and where what fits, but I think it's a pretty fortunate opportunity for this area that LIPA actually fits really, really well.
How about the staggered on your water, your drops? Like on the front side of the boom, on the back side, you know, going through there? Does that make any difference? I mean, enough difference to?
We have some like that. You talking about going over your truss rods?
Yes.
Yeah, we've got some
front
like
and
that,
back.
are really old ones that were set really wide.
Yeah.
We
and
would
double
put T's. Yeah, that's actually worked pretty good. I think it does a good job. It's a challenge to get through there and clean them out, walking back and forth.
Yeah.
Do 2 people. It's
Well,
not
you
easy.
walk out with one side and walk in with the
Yeah,
other.
walk the other one. Yeah, it actually works pretty well, especially when they're low to the ground.
Right.
You know, you get a really good distribution.
Well, I figured you'd be better than, I mean, all right in a row. You get a little.
Yeah, you have to
more
watch those
penetration
straps
maybe,
though.
or-
they'll move on you, and you'll walk out there and you'll get some this wide and some this
Yeah.
wide over time. So some of those that started moving a lot, we just put hose clamps on either side.
Yeah.
Just you saying like where the T on top does this on you?
Yeah,
Yeah, it'll hang up on a corn and
yeah.
twist a little.
It keeps you, plus doing it that way, it doesn't constantly move. You know, you get those hoses that cut at the
Yeah.
top. A lot of those we've been putting real heavy 3/4 hose on top for about 12 to 18 inches. And then regular hose below that. And that stopped a lot of that. We've extended out the years quite a bit doing that.
What are you doing for weights when you have those low drops? Are you focusing on?
We have the little steel, or the little metal ones,
Go on the regulator.
that we actually attach on the regulator.
We're still using poly weights. And on some of the half milers that we changed over to 30-inch space until we have the double gooseneck with the clamps on the truss rods. And I assume that's what you're talking
Mhm.
about. We
Yeah.
haven't seen those move yet. Those things are pretty tough to put on.
Yeah, it takes time. We've
After
had
a
some on
while.
there for quite a while.
Okay.
Yeah, they'll eventually start moving.
I know it's kind of neither here nor there, but all of those conversions and work at the top of the sprinkler, that used to come with a litany of caution. You know, there's plenty of dangerous things that you can do in your life, but repetitive motion, 12 feet in the air with electricity and water going, just word to the wise, be cautious when you get up there and do it. It's worth paying attention to.
It hurts.
Well, there we
All
go.
doesn't,
It does.
you get.
Bitten by 110.
Yeah, getting bit by any of that, or a little shock and then you're on your back, you know.
Okay, other questions?
I have a question for Jordan. So Jordan, you were at this dairy conference, and I assume they know this, but I assume they understand our water situation here in this area. But I see like the dairy next to us, they just continue to expand and expand. And we can't grow the corn silage that we used to. And we're converting more to sorghum silage. So do they have a long-term plan, or do they talk about that with you, or have you asked that question? or-
Well, I actually have. One of the comments that I made is that the dairy industry seems so bold, and that, we think about, they're concerned about today's milk production. But when we consider just the cost of building materials, and why is the solution just down the road? Why not, like you said earlier, use half the water, extend the water supply. Going from corn silage to sorghum silage, you can use almost half the water. Now, in my mind, we can rail in the grain, they need to
Right.
starch. Why not make up that difference in starch and energy with something else? And that was, really the emphasis of that, and I thought it was great that DFA actually is who put together that panel, because they recognize, this challenge and the need for it. But it's still amazing to see most of the dairymen in the room and the nutritionists still want corn silage. And then, again, in an ideal world, that's great. But when you are trying to dairy in a desert, you have to make some, I guess, you just have to be realistic.
Yeah.
Hey, Jordan, if the nutritionists came and wrote a prescription, do you think that the dairymen would make those adjustments?
I 100%, I think so.
Yeah.
And of course, the other thing is, though, I've wondered about this because it's like a crop consultant. A crop consultant is always going to be proactive, and I don't blame them. Their reputation's, for the most part, riding on that line. So the nutritionist, the same thing. All of a sudden, milk production goes down a bit. But I think if a nutritionist came in and made that recommendation, I think if we were realistic in hybrid selection and management, timing, all these things. And of course, a lot of it even goes back to, I didn't get a chance to visit with Braden about harvest timing necessarily, but I do know most choppers are going to harvest a cornfield before they harvest a sorghum field. And then that sorghum is just a little too far along. So the solution is, swap it, lay it down. People don't want the extra harvest costs, but I will say that does preserve the quality.
It does. We thought, I remember visiting with you a couple times about direct chop, but that just will not work because of the timing of it. And that's one of the reasons why we started planting our sorghum silage first, so that we would have our access to choppers before they get into the cornfield. Because
Yeah.
once they get in the cornfield, they're not going to a sorghum field. Not until they get to corn chop.
Yep, so yeah, early, fast, take it in, lay it down, take it up, good quality.
That's an interesting topic though, Harold, and the idea of converting dairy feed. It's an ecosystem that's changing dramatically and quickly here. It does make me think about some of the dairy operations I've seen in different places in the world where alfalfa is the primary feedstock and no corn, or ones that have a heavy dose of sugar beets for the carbohydrates, or almond hulls, or whatever the local byproduct is. It seems like there's some opportunity there to transition that and get something with less water shipped in to make up the difference and get back to being able to grow. I mean, we're moving back towards wheat, sorghum, fallow. There's some folks at Bushland that are like, I told you so.
Yeah.
I've been telling you so for a long time.
Yeah, the Ogallala will tell us what we're gonna grow. And I could probably lynch, but I really think we should drop our maximums. They're too high. I mean, if you can grow corn on corn and still make 280 and not even touch the maximums, then it's too high. We're not conserving our water, we're organizing it. Now we know where it's going, but we haven't really dropped our use. It's,
And-
Well,
it's
We're
down
old
to-
and strong. That's a strong statement.
We manage depletion is what we do.
Yeah, we manage, now we know
We
where
call
we're
it a
at. Where'd that
conservation.
200 feet of Ogallala go?
Yeah,
Out
right
there.
back there.
Out in the air.
Okay, so to that point, has the district looked at Q stable, and Kansas State talk about that? And because water's not static, you draw it down, but then it does recover because it's moving, up and down laterally, and they've talked about that. And there was actually an USDA OAP meeting yesterday morning that I was at, and there were some presentations by some engineers and hydrologists out of Kansas, and that's what they were talking about, how they're trying to determine in Kansas where Q stable is. At what point can we sustain irrigation but stop the continued depletion of the aquifer? And it would be so interesting to know what is that point, because when we talk about wells and saturated thickness in the aquifer, we know that, okay, just because you have 100 feet of saturated thickness, you don't have 100 feet of water. And we know that most wells are gonna cavitate at 20 to 30 feet probably. So you have about 70 feet of saturated thickness. Well, depending on the specific yield, now all of a sudden, when we really think about what we're managing and put it into real terms, maybe we're only managing, 15, 20 feet of actual water. So if there is actually a way to determine what Q stable is, then it's,
We're using probably 2 feet a year, roughly, and it recovers maybe half an inch. I think what people are seeing is the drawdown recovers, not the water level.
and that's.
Because
where-
we used, for a year, before the dairies were here, 20, 30 feet drawdown was typical. Now you're getting 100. That's because they're doing so many double crops. They're, triticale, cutting it, corn, cutting it off, planting triticale, and you're running wells all year. And so that drawdown is constant. And eventually it moves out to all these other areas. We're not seeing as much on this side of the highway, but it hadn't been that long since we had 700-gallon wells that are running 300 now. And
In
that's,
'76, when the farmers went on strike, the water level come up 18 inches, according to North Plains Water District.
Well, back during the 80s, when we had these huge set-asides and pick and roll and 50% set-asides, I think in the eastern counties, you saw water levels go up also. Because there just wasn't that much production.
So in northwest Kansas, where we've got pretty strict water restrictions, we have seen that drawdown slow immensely. We're less than a 6-inch drawdown net right now annually. And a lot of our groundwater management district, but we're also teetering at 30% water restrictions of where we were just 9 years ago. And we're getting ready to take another 15%, starting in 27. So, it's not what everybody wants to hear. Everybody doesn't want to say, I want to give up water, right? Our water is managed differently and owned differently than what y'all are down here. But I firmly believe it can be done, because we're seeing it locally. I mean, we're seeing guys locally make irrigated acres work strategically with sometimes 10 inches of water. And we don't get any more precipitation than what y'all get down here.
But you're a little bit further north.
You'll have more sand,
The
more
problem,
sand
Nathan, is
No,
we're,
not saying.
in the formation though.
Texas is a right to capture state.
Right.
And so, you know, and that fight's gonna be, that's a fight yet to come. It's gonna happen, and we'll see what happens with, you know, private property rights. And
I was curious about your opinion on the Fermi fight. The numbers they were saying, the amount of water they're gonna use to just destroy the area, it's like, you know, do some math here. Like one section we have in Spearman uses double the water that Fermi uses. So this is nothing.
Yeah,
I mean, they're talking millions of gallons, but I don't think people realize how much a farm uses.
A million gallons is not a big number.
No. And, I mean, I get it in certain areas, but I'm not arguing for it, but I'm just saying their scale is, they're totally, they don't understand.
yeah, their numbers didn't make sense.
It's not much.
I mean, the caution on some of this is not to fearmonger either, but recognize that there might be some solutions and stepwise movement to get to those solutions. I didn't share some of the other properties I'm looking at. There's one that I've managed had it for about 4 years. Pistachios, almonds, peaches, figs, and open ground where dairy silage is grown. And it's in Central California, which is subject to SGMA. Okay, it's the Sustainable Groundwater Management Act these are the models that I do get nervous about, Harold. The state basically said, farmers, here's what you're doing. And the state does what California does, overreached everything, and a previously unregulated area is now hammered by these constraints that you are going to reach this sustainable number. Well, when that ranch was purchased, that sustainable number was modeled at something like 1.5 acre feet a year. Reasonable. Each year it's gotten smaller. Right now we're working on, by the year 2029, when this goes into place, that property is going to be 0.69 acre feet a year. So that 10-inch number on a ranch that's already got 300 acres of a 50-year pistachio crop on it. And so now everything else goes to fallow. And so this becomes the model, is what do we do now where you've made this economic commitment, this investment, whatever your infrastructure is, but you're gonna have to carry 900 extra acres to take care of that 300 acres. Those are the nerve-wracking things that I think.
Valero does.
It's what they have to do, yeah.
Yeah.
But these are the things that I think you have to be creative, and rather than put your head in the sand on, look at these methods where you can be profitable in the midst of that. And that's where you can look at some alternative cropping, say, or going back to these rotations that I think you were implying. The aquifer's gonna tell you, but at some point we have to be honest with what the aquifer's given us.
It will change.
It will.
Just like when I came here 40 years ago, it was 35%. In our survey over the last 9 classes, I don't think we got 3,000 acres total out of 670,000. And the change will come, and it may have to come down to the water district having to cut those restrictions a little bit more, but one way or the other, you're gonna run lower and you're gonna be changing your ways, just have to become more advanced. I mean, that's the way it is. We haven't got that corn variety that can grow on 2 inches yet, but I'm sure they're working on it. Okay, one last question for the panel. Get this thing, yes, sir.
This might be kind of an uneducated question, but where is the water going? Because matter can't be created nor destroyed. So where is all the water going?
Yeah, that's a really beautiful question. That kind of takes us back to the start of where my presentation was. So when you look at that water moving up and through the plant or up into the atmosphere, when you pull that water from the aquifer, it's satisfying this vapor pressure deficit in the atmosphere. And that water in the atmosphere moves everywhere it wants to go. When the conditions get right, water that we're putting in the atmosphere here likely is moving east And when the conditions get right, the pressures change, gets enough dust in the air, bam, it's gonna drop, and it rains again. So when you talk about a water balance of water either being created or destroyed, really what's happening is the water moves. But the location of water is critical, because you can't really put that water in a tanker and bring it back. We've used it beneficially here. It's not been wasted, it's been actually used. The material isn't taking a whole lot of water in the silage, just a fraction of what's applied, but it's been discharged somewhere else. So when you get more coastal, you think about that rain cycle, it can pick up ocean water, move it inland, dump it, goes back to the ocean. That cycle's pretty nice. But where are we located at? Literally the center of the continent. And we've got Mexico below and Canada above. So right here is as far away from a huge body of water as you can be. So our only real access is that water below. It comes up, does its job, and then it's off to wherever the 4 strong winds are taking it.